Welcome. I am Farid Taleblu, an MSc student in software engineering at the University of Calgary, Faculty of Electrical and Computer Engineering, studying under the supervision of Professor Far. In January 2020, I began working on a paper related to autonomous vehicles. The title is Towards Safer Autonomous Driving Systems. Deep, unsupervised machine learning approach for learning driving scenarios in an unknown environment. Almost 1.5 million people die per year in traffic accidents, and 20 to 50 million more are wounded or disabled. The primary cause of death in a car accident is a crash due to unreasonable driving behavior. Seeking a way to define the driving characteristics of the driver can help to prevent endangering the lives of occupants, pedestrians, and other vehicles. Having a data set comes first in any research. In this research, we aim to provide a comprehensive driving behavior detection algorithm, but a complete and accurate database is not yet available. Using the lowest parameters and the lowest level of dependence on data attributes, we started research and development. We began with the public transportation data provided by the City of Calgary's Open Data Portal for this purpose, which is available to the public in an open source format. Here you can see the information about the dataset. We use these attributes: average speed, heading, longitude, latitude, vehicle position data. The data contains 19.6 million records related to all the movements of the buses of Calgary from May 2018 to May 2019. An example of a single record has been illustrated here. Two hypotheses have combined into this strategy: AI safety indicator next to AI abnormal driving notifier that in separate pages will be discussed. The first idea is to introduce a model that, after obtaining a time series data of the route traveled by driver, can allocate a safety index between 0 and 1. To obtain this index, we first map driver's behavior on safety parameters and obtain the safety factor using the neural network method of machine learning from the methods of classifying knowledge. Based on the current details on how the driver is going, the second theory is to be able to estimate the seconds ahead and submit the next second's forecast to the safety monitoring system. And the alert system will start operating if there is a risk in the analysis results. We use the LSTM algorithm in this section to predict the data. The rationale for choosing LSTM is because the program is using a structure founded on short-term memory processes to create long-term memory. The time series can be calculated with the required precision by this algorithm for some seconds later. In this regard, we can predict the safety of predicted driving behavior and alert it to the external systems. In this journey, we will face 4 major challenges. First, to construct an artificial intelligence model, the quality of selected datasets and attributes may not have the potential to lead to appropriate results. Second, we are working in an unsupervised data environment. Currently, we don't have any label for our records to use in the machine learning process in order to get better results. Third, so far I have 3 real-time system implementation solutions. Use a built-in device that needs sufficient resource to respond in a timely manner. Obviously, it is expensive. 2. Use the cloud infrastructure to submit and process information outside the system that needs a reliable and secure network. Third, combining both to have a hybrid which will use both algorithms, but it will have its complexity. And all the above should be experimented more for finding the optimum one. And the last one, it's obvious that the drivers should accept the consent of using their movement data to distinguish their driving behavior. Now the important part, the benefits of the proposed system have been shown in the following. In the event of extreme fatigue or drunkenness, the device helps to alert the driver and instantly avoid driving and prevents serious accidents. Second, this technology will support the highway law enforcement system a great deal. In this way, it will recognize cars that are driving erratically and out of the ordinary at any moment. Third, it is possible to monitor anomaly-related incidents in the long run using this technique to provide an average measure of how drivers are operating. For insurance agencies, this knowledge is a big help. It can be used in autonomous vehicles as well. In regard, the algorithm will not be expected to operate to stop the AV in high-risk situations, but it can help for supervisory organization to check which AV company has the safest driving style. In the summary, modern driving tracking systems use the following approaches to monitor driving behavior. First, face image recognition system. Second, driver awareness identification using the touch surface of the driver's hand with the steering wheel. And third, using how to touch the accelerator pedal, brakes, or adjust the steering wheel rapidly, senses the driver's alertness and regular driving. Or various approaches but involving multiple sensors inside or outside the car. In this proposed process, however, only the speed of the car, its heading degree, latitude and longitude need to be identified, all of which can only be obtained from a GPS sensor. In this respect, however, we are in the middle of an ongoing negotiation with some telecommunication operators such as TELUS to get more detailed information about vehicles. We hope we will get 5G data and differential GPS sensor information that will lead us to have a well-trained model for prediction. In this regard, I would like to thank Professor Fa, who has always accompanied me on this trip, for his tireless assistance. The second was from Dr. Emad Mohammed, who, in data sciences, led the right movements methods. And finally, all my friends, colleagues, and members of the Faculty of Electrical and Computer Engineering of the University of Calgary assisted me in our academic meetings. Thank you.